Okay, so let me welcome Mr. Classon. Maybe let's introduce yourself a little bit. Also, the company, JLR, everybody knows, but maybe Nitra. What is in Nitra? What is new? And yeah, and then we start.
Okay. So, good evening, dobre večer. This is about the only Slovak I know for now. So we need to speak English. My name is Christian Classon. I am a German national, and I am an automotive guy ever since. Before I joined JLR, my major career was in Ford Motor Company, where I grew up, and I gained my first experience. From there I went to China, where I worked for a Chinese company, and I stayed in China for some years, building also a very interesting and exciting complete new factory. But after some time I got attracted by company Tesla, which you might have heard, building electric vehicles, and that dragged me over to California. And but then JLR came along, and I had the chance to join JLR for, again, building a complete new factory. This time, as you know, in Slovakia, we are building a complete, entire new greenfield factory in Nitra, and we are going live this September. This is when our mass production is going to start. So whoever has not seen the factory in the media and the news or on the Google, I can only encourage you to do so, because our factory is real and it's already producing cars. Good. So some more about the factory or the company. We are recruiting like hell, so we need people. We have currently 1,100 Slovak people, which is a massive improvement. 1 year ago we were also here. 1 year ago, Tony, what, 300, 200? Yeah. So in 1 year we recruited more than 800, 900 additional people. So we are now at 1,100. We employed in the beginning of April our 1,000th employee, who happens to be in my factory, which is great. Yeah. And yeah, so we look for talented, good people like yourself, who are willing to be creative, to shape, to form, yeah, and to help create our future history. Good.
So the main topic of this panel is aluminium. Okay, so my question maybe also for other students: why aluminium? Why is it so important for you? Probably also for Nitra, for JLR also. So maybe why is it the topic? Why?
Okay. So maybe I pass the question on. What do you think? Why is aluminum important? Just throw me some ideas. Low weight. High density. High what? Evidence. There's a lot of. Yeah. There's also a lot of steel. So yes, all answers are correct. Aluminium is lightweight. Aluminium is something that we in the company needed for our cars. Our cars are big. Big means weight, usually. So we build these big cars, not just since yesterday, but since a long time. A Range Rover, a previous Range Rover, the old Range Rover, was built in steel. That car weighed 2.5 to 2,700 kilograms. That's a lot of weight. So weight means a lot of consumption of fuel. So we went on a journey starting beginning of 2002 to use aluminium to offset some of this. First in trials, and then later for mass production. So our first car was the XJ, built in 2003. 50% of the car was aluminium. Then we went into the bigger XJ 2007 model year, which was that long stretched limousine that you may know. Also this one was done in complete aluminium. It is required to offset weight. So weight means fuel consumption, yeah. And for us building those cars, this is one of the major contributions. Nowadays, with all the electrification, with all the batteries, you know, the Tesla is a heavyweight vehicle. It's really, really heavy, but it's not the car that is heavy, it's the battery that is heavy. So now, today, you need to offset the weight for the batteries with intelligent materials. So this is another argument why now aluminium is quite important, even nowadays. Yeah.
Maybe a question from my side. If a company is like majorly changing from steel to aluminum, which JLR is doing, is it only change the material, or does it inflate a lot of other things like R&D, like testing, like is it like a company-wide impact, or is it just to change one material for another?
No, so this is a massive impact. The material is lightweight, which is great, but it also has limitations, and it also has disadvantages. So lightweight means in aluminium you need to offset by thickness. So a modern steel, and you know, you have heard about high-strength steels, are very strong materials which are very thin, and they become thinner and thinner. In aluminium, you need to offset this by thickness. So you need more aluminium to achieve the same result. That is a big of a problem. On the other side, also joining aluminium requires certain methods to process it. I happen to be the director for the body shop, so I put all these parts together. How do I put the parts together? I cannot weld them as I normally would use with steel. So what we do in JLR is we do a lot of riveting. Have you heard about riveting? Rivet? In Slovak? Nitrovanie. Yeah. So that requires a different joining method. This is a very expensive joining method because the materials, the rivets, the small little tiny rivets, which we are using millions and millions every year, are really expensive. Secondly, the guns that you need, the force to put these rivets into the body, are really, really expensive too. So a weld gun, compared for steel, yeah, is like half the price of a rivet gun. Yeah? You need holes, right? So, no, we don't need holes. In this case, we are riveting through the material. So that is a different method of joining. But the joints, the rivets itself, are not enough because they will not hold the parts together. So we need to use a lot of glue, adhesive, in addition, because that gives the strength in the car, which on a steel car, you don't need as much. For aluminum, we need to have a lot of kilometers of adhesive in the car as well. Yeah. So there are also limitations in drawing it in the die, pressing, stamping. Yeah, steel, you can do really nice crispy shapes. Aluminum has it as a different porosity, so you cannot put that in the same die and draw it. You cannot achieve the same results. You cannot achieve the nice radii. The radii are bigger. Yeah, if you go down and look at the Tesla in front of the building, you will see that the radii on the Tesla are really big. Yeah, that is because of aluminum. So there's a lot of different implications when you use aluminium.
A little bit about Nitra. Is it only assembly plant, or do you make like all the processes, all the process you need for a car? So maybe to explain, maybe everybody knows, maybe not. Maybe to also explain if you are treating the aluminium completely in the plant, or you are buying already buy parts which you just weld together. Maybe to explain also that a little bit. Okay, so in our UK factories, we basically have our pressings. So let's start differently. So cars is built with starting with pressings. Yeah, you have a stamping shop that presses the parts. Then you need a body shop, which I am heading, to put all the parts together. From there it goes into a paint shop. From the paint shop it goes into an assembly shop.
Yeah, and obviously you need a big logistical competence and a logistical center to provide all the parts. So in the UK, the press shop, the stamping shop, is inside our factories. Most of the pressings in the UK come from internal press shops. And there's a reason for it, because it's our core competency. We know how to deal with the material. We know how long the material is usable. Aluminium, didn't mention it before, but aluminium is not like steel. Aluminum has a shelf life, so you can only use it a certain time. Yeah, after that, it changes the characteristics. So, and that is somewhere between 6 and 12 months. Yeah, this is why you need to manage that material much, much better. That's one of the reasons why we have that in the UK internally. So in Nitra, building a complete new site, we invest 1.5 billion euros, and we ran out of money. So we needed a press shop, and we found a good partner. It's an external partner. It's company G-Stamp that you might have heard. It's a worldwide, well-known press shop and die supplier. So they are right outside our fence line. They're sitting right next door, and they will provide the big pressings to us. Yeah, which for us is gonna mean that we now have to manage a supplier that has not got the aluminium experience like we have internally. So we gotta manage that. It's another challenge, but we will manage that as well.
Okay, we have one question, but maybe keep posting on slide. I have one question. Is the shift from steel to aluminum linked only to weight, or is it linked also that in the future JLR is aiming for electric? What was the main decision? It was like really like everybody's just emission stuff like that, or is it the strategy to go more electric like it is?
Right. So initially it was weight and it was fuel consumption, and I told you before about the first generation Range Rover, which was very heavy. When we went to the second generation Range Rover, we reduced the weight of the car by 450 kilograms. This is a quite big amount of weight saving. So that meant that we actually saved more than 1 liter of fuel consumption by reducing this weight. Yeah. So it's fuel consumption. We also reduced emissions, so depending on the weight balance, but you talk about something like 10 grams per 100 kilograms. So that means with this equation, 450 kilograms is something like 45 grams per 100 kilometer, per kilometer, not 100, per kilometer that we save. Yeah, so it is like this. Nowadays, the challenge becomes more obvious because of the electrification. So now we need really to save weight, because now we have more batteries going in, which are really heavy. We have more electronics going in that is heavy. Yeah, we have some offset because we don't need an engine as big anymore, but it's still really heavy. So there's a need for materials, for new materials. So that brings me to steel. Is the steel era over? No, it's not. Yeah, every car manufacturer is still looking at a high usage of steel. Yeah, the steels get much smarter. They get more powerful, and they get lighter as well. There's carbon fiber that is being explored to use carbon fiber, which has manufacturing challenges, but that is something that is going into cars. So what nowadays becomes more and more important is an intelligent design, where you take certain materials for certain purposes only. So it's not going to be like we're going to have all aluminum cars in the future. Yeah, it needs to be an intelligent design where you take aluminium where it's required, you take carbon fiber where it's required, and you take steel where it's required. This is where it's going.
Okay, so our question is basically, do you see the future in 3D printing aluminum parts? Is it something that what do you think about it?
It's quite interesting. I've never thought about it, but can you imagine that you can, in the time that a press actually presses a part, and here we talk about, Tony, 20 hits per minute. Every 3 seconds, we can press a part. Are we going to be able to 3D print a part in 3 seconds? I doubt that. So maybe not in my life, maybe in your life. Yeah? Whoever brought up that question, note it down, make a patent out of it, and then work on a solution, and you will be rich in the future.
Or maybe not automotive.
Yeah. So we use 3D printing for other purposes, for spare parts. That is very popular right now, that you basically produce wear parts or spare parts on a needed basis. Don't buy all the stuff, put them in your storage, produce the parts when you need them. Yeah. So that is a popular method of using that technology.
We have another one.
So Joseph, where's Joseph? Okay, do you know what Industry 4.0 is? Yeah? Good. Because we are still trying to figure it out. So it's a big topic. Very big. Everyone talks about it. If you talk to people, okay, what does it actually mean? Then nobody knows really. So for us, yes, we are on the journey, and Tony happens to sit here as well, and it happens that we both are actually heavily involved in leading this initiative. Yes, we do Industry 4.0. For us, Industry 4.0 is connectivity, data connectivity, big data. You heard big data. Again, one of those big things, but what does it mean? Connectivity. Use the data that you have, bring it intelligently together to create a context that you understand what's going on. It sounds logical and easy, but if you are in an industrial environment, you will notice that you get flooded with data, but to really use it is really, really difficult. So we in Nitra, we are connecting our plants, we are connecting processes, we are connecting people, we are connecting robots, technology, machines, buildings to understand what's going on, and that we do for one purpose, to become more efficient and to save cost. So we want to know where is the light left on in that big factory. We want to be able to see it and to switch it off. We also want to see why is the robot in that line suddenly consuming more energy than it did yesterday. Yeah, because that tells us that tomorrow it will break down. So we do these kind of things, and we have very exciting projects which you can only or easily do when you build a new factory. Now is the time for us to do it, and we are heavily involved in this. In factories like VW, PSA, very difficult to realize it in an existing environment. Yeah. But yes, we do. Right. So, anonymous. Who's anonymous? There he is, Mr. Anonymous. So, yeah, you probably referred to, you have heard, you have read, you know that it takes a lot of energy to produce aluminium. Aluminium more, yeah, more. And that is because you need a lot of heat, because of the characteristics of the aluminium itself. You need a lot of heat. So, on the first, in the first sight, it seems that it is it paying off, and is that energy bill not consuming your other benefits? So we have done an analysis, and for us, if you look at the overall cycle, it is actually a quite beneficial energy bill, and it is environmentally really, really friendly. Yeah, you might need a lot of energy in the first place to create it, more than with steel, but you will have less CO2, you have less fuel consumption, yeah, and if you put that all in the overall equation over a lifetime of a vehicle, aluminium you can also put back in recycling and use that quite efficiently in recycling. the energy bill is actually quite favorable. Yeah, really favorable. So it's a good business. Yes, that is a method. Yes, you can do it, but again, you cannot TIG weld in a mass production. We talk about mass production. We talk about in JLR, our cycle time is 2 minutes. Every 2 minutes, we finish one car, we finish one body, we press, we ship one car out of the factory. So that process is not as suitable for mass production. Yeah, and it's not economical as well. So I am more looking into doing resistant spot welding with aluminium. That is the most economical way. It's the least intensive equipment because we know how to do resistant spot welding, and it's the cheapest method. You don't need rivets as supplement material. You just need a proper weld gun. Yeah. Which in the past used to be difficult because the aluminum oxidides, and after doing a certain number of spot welds, the electrode oxidides, then you lose the current that flows through because of the oxidation layer, and that means you need to go back to your tip dresser, which takes away cycle time and so on and so on. So it wasn't in the past very economical, but technology has moved on, and we have developed methods of making it mass production affordable. So today, yeah, we can resistant spot weld aluminium. Yeah, that is doable and possible in a mass production.
Okay, maybe some final words to the audience, to the students from your side. What would maybe say? Advice?
Some advice, okay. So, some advice. You are in a position where I have been 22, 23 years ago. You are finishing university. You are asking yourself, what's coming next? What can I do? What makes sense? What is my interest? It's a difficult decision, but it's actually not so difficult because there are lots of opportunities. You are in Slovakia, you have a big opportunity because your country is on the move. You have companies like us joining, you have other companies here, you have technology companies. For you, there's a lot of development in this country. So I think what my advice to you would be very open to this. Be open to look for jobs that take you to the limits. Be open-minded, be proactive, try to be somebody who has principles and try to shape the future, because we are all relying on the next generation. So what we need in our company right now, what we look for in our company is young, motivated, talented people that might have not the best grades in the studies. Yeah? If I do my interviews with candidates, I'm not looking for the best grades. What I'm looking for is character, personality, interest, motivation, because you can do a lot, you can learn a lot, you just need to be willing to do so. So if you are motivated and willing to do so, then there's a lot of jobs and a lot of future out there for you. Yeah? But it's depending on you as a person and on your motivation. So that is what I took, that is what I experienced over my life of my career, and my career was very colorful, and it was not straight. It took me to places that I never thought I would go to. If you would have asked me 10 years ago, would you work in China? I would have said, China? Never, never ever. So I went to China, and it was one of the best times of my life, and I must say, wow, great. So be open to it, yeah, and that would be my advice.